Okay, last problem I'm going to talk about, number 18 here. Find out solutions of the equation interval between 0 and 2 pi, including 0 and not including 2 pi. And we have this lovely trigonometric equation here. You got to be able to first put it into one trigonometric form there. You have to remember your Pythagorean identities. You got to remember these for your test tomorrow, or on Tuesday. Sine squared plus cosine squared equals 1. 1 plus tangent squared equals secant squared. And then 1 plus cotangent squared equals cosecant squared. Okay, so what we're going to use is we're going to use that third one to solve this. You got to remember these three right here. The first one you've probably seen enough. Sine squared plus cosine squared equals 1. That's very common, but you have to remember these other two right here. Okay, I'm going to now substitute, because I know 1 plus cotangent squared equals cosecant. I'm going to substitute this in for cotangent squared up there. That's what I'm going to do first. So I have 2 cosecant squared x minus 1 minus 3 cosecant x equals 0. Distribute the 2. Put it in standard form. Okay, that's our first few steps right there. You need to be able to set it up correctly, just as I have done so right there. You need to notice that this is a quadratic equation. So if you want, you can let u equal cosecant x. So you have 2u squared minus 3u minus 2 equals 0. Now you need to factor this. You need to factor it however you like to factor this. Okay, we can use AC method here. What two numbers multiply to get -4 and add to get -3? It's -4 and 1. So we're going to split the middle term. Factor by grouping. Zero product property. Solve for u. Unfortunately, we're not just done right there, though. We have to now solve for x. So you have to solve for x there. Remember that cosecant is 1 over sine. So if you just want to change it, you can say sine of x equals the reciprocal of -1/2, which is -2, or sine of x equals 1/2. Okay, sine of x the range of sine of x is only between -1 and 1. This is an extraneous solution. So you only have sine of x equals 1/2. Okay, where does a y value in a unit circle equal 1/2? It's pi over 6 and 5 pi over 6. So that's my answer. I only had 2 answers for this equation. If you can remember that steps, you can do it this way. Yes, there are a lot of steps along the way here, obviously. Okay, we've had a couple problems on this before, so hopefully maybe it seems it's becoming a little bit easier to do. The other thing you could do if you really wanted to do it this way, I probably wouldn't recommend it, but you could stick in values for x. Since this is a multiple choice test here, you could stick in these values for x and see which ones works. That's like how we did number 15 and how you would do like number 16 too. Like you do the synthetic division like we talked about. Okay. So that's how you would do it. Like we talked about how you would do the synthetic division. You can try to stick in values here too, but the problem again is you don't have cotangent nor do you have cosecant in your calculator. So you would have to type in cotangent is cosine over sine, and cosecant is 1 over sine. So you'd have to type all that in there. So you could type in like 3 pi over 4 if you wanted to. I would not recommend that though. I know this seems like a harder method, but this is what I would recommend. I would recommend factoring by grouping here, especially if you want to try to get, if you want to be able to show your work there. I will show you right now though if you want to try to do it. If you do want to try to type it in, I can show you how to do this. So again, let's try pi over 4 here. So I'm going to have parentheses 2. I'm going to put this in parentheses. Let me change my mode to radians. Okay, I'm going to have, again, cotangent is cosine over sine. So I'm going to have cosine of 3 pi over 4 divided by sine 3 pi over 4. All that in parentheses. I'm going to square it because it's the squared. Minus 3, and then it's parentheses 1 over sine 3 pi over 4. Okay, that equals 0. So that does equal 0 at 3 pi over 4. But the problem is you have to test all of them, right? You have to see if all of them would equal 0. So, you could take the same entry. Ooh, I apologize. That was negative 7.5 times e to the 12. I thought that was e to the negative 12. E to the 12 would be a huge number. So this is not 0. This is not 0. So we know that this is not an answer. But you have to be careful. If it is 0, then you have to still check all the other answers. That's why I don't think it's as convenient to do so. So we could try here. Well, we could try 5 pi over 6 if you want, so we can see that that is an actual number. Oops. Oh, okay, let's get this up here again. I'm just pressing second entry. I want that previous entry. You can see we were doing some other stuff there. There we go. Okay, I'm going to put in 5 pi over 6. So I'm going to change all these numbers to 5 pi over 6. You could do this on the test, again, if you really want. Again, I would not recommend this, though. Ooh, I forgot to put in a divide there. Oy, that might have changed the answer some. Well, there, that's equal to 0. Let's go ahead and try that 3 pi over 4 again. I forgot to put it in there. Okay, there we go. That was 3 pi over 4. You can see the answer is not 0. So you could try this if you really wanted to. You can type it in. You can see I screwed it up. I forgot that little divided sign on the first time I wrote it. See, right? I forgot that divided sign. I mean, and that screwed me over. But of course, this has just as many computations. So unfortunately, you're sort of in a rock and a hard place. Again, I would recommend doing this method when I would do this problem.